This is the latest addition I have to my pool controller. I already have the swimming pool connected to a Wi-Fi enabled Raspberry Pi controller, and what it does is it reads the temperature in the pool through this Dallas one-wire thermometer, and depending on what the temperature I have set for the heater, it'll turn on the pump, turn on the heater, and shut the pump off when it gets up to that temperature. And I can control what that temperature is and whether the heater's on and so forth over the web. It's a web page that I put together. It's pretty simple. And the server is actually on this Raspberry Pi. The Raspberry Pi runs a complete Linux system. And normally you don't have the monitor hooked up to this, but it's useful for debugging, and it kind of shows you this is a complete Linux system. I just decided to reboot it just to show you. Now what I wanted to do was to separate the thermometer, which goes actually in the pool, from any connection to any of the rest of the electrical system. For the Raspberry Pi, to the pool pump, just for safety's sake. I mean, I suppose it's possible that there could be a hot thermometer in the water, and that's less than optimal. So I wanted to have the thermometer just completely separate. And to do that, I wanted to set up a wireless link. So here's what I did. I hooked up the one-wire thermometer, it's a Dallas unit, and connected it to an Arduino. Now this doesn't look like a regular Arduino board because I took the ATmega chip out of the Arduino, and here's the crystal, and made my own little Arduino board. The reason for doing that is that if you make a bare bones Arduino yourself, it runs at much lower power. And I want to run this off of a lithium polymer battery and have it charged by a solar panel here. So I wrote the software to load onto the Arduino chip, and it samples the temperature, which it reads in centigrade, converts it to Fahrenheit, and transmits it wirelessly using this little Xbee. These are these nice little Xbee radios, and that has a link to this other Xbee, and that's connected to the base unit of the Raspberry Pi. I have a Raspberry Pi right now just identical to this one with a thermometer, but the one right now is actually wired into the Raspberry Pi. This way there will be a separate wireless link. So here the Linux system on the Raspberry Pi is booted up, and it's got a script that reads from the Xbee, and that Xbee gets a signal from this Xbee, and it's told what to transmit by this little microcontroller, and the program is uploaded through a FTDI cable that plugs into this little header, and it's powered by this lithium polymer battery, and that's charged by this solar panel. Now you can't just hook up a solar panel to a lithium polymer battery, because if it overheats, you could have a fire. So this is a little controller board that will take the voltage, take the current from the solar panel, and it will appropriately charge the lithium polymer battery. And because that runs at about 3.7 volts, 3.7 to 4.2, that has to be run up to 5 volts. Now the Xbee actually runs at 3.3 volts, and so does the ATmega. It can run at 3 volts, 3.3 volts. So I'm going to reset this to run at 3.3 once I get the low power regulator. That'll reduce the current even further, but currently it runs at between 50 and 55 milliamps. And it turns out that with sleep mode, hibernation, you can get the Xbee to turn off, and that cuts the current down to about 30 milliamps. And presumably with the low power modifications, I can get it much lower than that. So anyway, this still ought to be able to run about 10-12 hours, and if you get a larger battery, it ought to be able to handle that. I don't know if this one actually will be able to go more than 12 hours, and we'll just have to see. In bright sunlight, this should be able to put out about 3 watts. So after several hours in bright sunlight, I ought to have the battery charged, and hopefully, if it's cloudy, it'll be able to charge it up at least until the sun comes out. And here in Southern California, that sun usually comes out pretty frequently. So, not too bad. I should be able to get the current down from this. But this shows a lot of the stuff that you can do with Arduinos and Raspberry Pis, and with these neat little 2.4 gigahertz Xbee radio units. Here you can see every second this one's receiving. You can see it flashing when it receives a packet. And here's the one that's transmitting. Yeah, it's transmitting regularly. So it's working out just great. And hopefully when I get this mounted outside, it'll work just like it does here. Okay, here we are by poolside, and the thermometer tip is in the water here. Runs over to the AT-Mega Arduino unit. Here's the solar panel. Lithium polymer batteries, Arduino, charger unit. Here's the boost that brings it up to 5 volts, and the Xbee. Well, hopefully this will stay charged indefinitely. And that's about it. Okay, let's go over to the pool pump and pool heater and the receiving unit. This connects to the pool controller. Here's the Raspberry Pi. It's running an Apache web server, and it connects to the internet with this Wi-Fi dongle. Here's a relay for the heater and a relay for the pump. And here's the Xbee. And I think you can see the Xbee is receiving a temperature packet about once every second. So this is working pretty well. I have a thermostat embedded in the software here, and this is software that I put together using libraries that are readily available. This is uses a Python daemon and some Python scripts for changing the pool temperature, the thermostat, the setting, and I can do that all over the internet from work. So I can reset the pool temperature, turn on the heater several hours before I get home from work, so that the pool will be warm when I get home. And the thermostat is at the other unit, and it's not electrically connected, so there's the safety factor there. And that's running off of an Arduino, and the Arduino environment allows you to put together sketches, as they call them. They're scripts that run on the Arduino, and there are a lot of libraries out there that allow you to play around and put those scripts together without too much effort. Hope you enjoyed this.